Put the heading relative velocity. Relative velocity. Okay. Okay. So have you put? So you need 120 pages exercise. You can write this under the applied maths and dynamics, right? So relative velocity. Once we finish that VT graph, as soon as you can write down uh, the heading. So if you have old VT graph book, then you can continue, or you can have a new book. Okay. Right. Any problem, guys? Any doubts? So I have before I start. Uh, right. Okay. Okay. So guys, the relative velocity, I will put the heading. It is better to have the separate book if you have, or don't combine with other static. Always dynamics. This is coming under the dynamics. And pulley, after pulley, we have to learn wedges, right? So then don't write after the pulley. Don't write velocity, relative velocity after the pulley. Keep that space for the wedges. Okay. So relative velocity, actually, so we quickly, I'll point by point, we'll go today theory, and we can do some questions also. So I can explain that theoretically to finish all type of questions within 4 classes. Theoretically, I can finish all type questions within 4 classes. I'm going to take 5 or 6 classes now to finish with some other questions also. So after that, later we will do revision, full revision, and during the revision we will do various type of questions, right? So questions are endless. No, any lesson, for any lesson, questions are endless. Okay, so we can't say we have done all the questions, right? So only thing is we can finish the theory, then we can do the past papers related to that, then some model papers and school papers, term papers, and something like that. Okay, relative velocity. Have you heard about the relative velocity? So what do you mean by the relative velocity? Very important factors in the relative velocity. So if I talk about the relative velocity, I need to talk about the Newton, but I need, and also Einstein. I need to talk about the Einstein. So now I'm not going to talk about the Einstein because he took us to the quantum physics, which is not belongs to us now. Right now, what we are not learning here. So we are learning under the classical mechanics, Newton's classical mechanics. So under that topic only, we are going to learn the relative velocity. So under that topic, 2 things are very important. One is time, other one is space. Okay, one is time, other one is space. Okay, so what do you mean by the time and what do you mean by the space here? So what we define is there are frames. Okay, so there are frames. Okay, so this is what we are going to learn, right? So what we are going to assume in under the Newtonian relative velocity lesson, we are going to assume that under any frame, okay, about any frame or in any frame, time and space doesn't change. Any frame, time and space doesn't change. This is the uh, as assumptions we have made under this lesson, right? Is it clear? What do you mean by time and space doesn't change? So for an example, I can explain like this. Okay, so there is a car. Say this is a car, and there is a driver, and there is another car, and the driver also, and you are here. You look out of this, and someone is flying uh, in a plane or helicopter anywhere. So the pilot also saying this. Okay, right. So they came. So they have the stopwatch. Okay, these people have stopwatch. Okay, so write down not write down means the stopwatch, it shows 0000. Okay. At the same time, they are going to on it. So for this guy, this guy, this guy, and this guy. Okay. So you see, after 10 seconds, after seconds means 10 seconds means according to this person. He is in the frame of the earth. Okay, he doesn't move, he's waiting. Yes. After 10 seconds means according to this person, after 10 seconds. Okay, so they put a break here. Okay, and he stop. Once he sees that these two cars are having the put the brake and they have the displacement, say according to this person they say 20 meter. Okay, so that means his frame, so he can say 10 seconds, after 10 seconds these two uh, uh, cars are stopped and they have the displacement 20 meter each other, right? In between they have the displacement 20 meter, if you ask. So I'm asking the same question to this driver. What he will take? Will he tell, no, no, it took only 5 seconds for me to put the brake? Will he tell that? Or will he tell the same 10 seconds? So all are started at the right time. Okay, so right. So what he will tell, he will also tell, okay, it took 10 seconds because in the soft stop mode. This one, okay, this one, same. What he will tell. So if it's 20 meter, according to this person made the displacement of these, displacement between these two cars. So what about these two people? What he will tell, the driver will tell. He will tell he is in the 1 kilometer. No. So same 20 meter he is going to say. So this the driver will say, okay, same 20 meter. He's in front of me in 20 meters gap. So this one also will say that is 20 meter. Okay, if he can measure. Okay, so that's why any frame. So this guy is in the velocity and now he stopped actually. But this guy is moving, this guy doesn't move. So any frame that time and space doesn't change. And time will change when you come to the quantum. That means if you can travel in a speed of light, then time will change. Sorry. Okay, so we won't talk about that hereafter. That's a very important, too important. So why I say time doesn't change? For an example here, the easy example I'm telling, because this is in a physics question. It's mechanics. Okay. Okay. Can you hear me? Can you hear me? My voice? Can you hear me? Let's see. Okay. Right. So one simple example, I'll tell you. So write down simple example. So we'll start with the example, right? We'll start with the example. Quickly, I'll just. Okay. So that's fine. Okay. So simple example. We can start with the example. So what is the example? So there is a particle here. There is another particle here. The gap is 100 meter. Okay. This guy is moving with this guy moving with a 40 meter second minus 1. This guy moving with a 60 meter second minus 1. At t equals 0, they just started. So this is projected. First question, will this A meet the B? Tell me first we have to clarify know that whether you are able to understand. Then only know we can see. This guy A can reach the B. Oh yes, yes. Why? Because this velocity is higher than this. So normally if you do that, so what is the method to do? Normal method. So we say here, and this is right. So after some time, we are meeting together. So this is t equals 0. This is t equals t. We don't know. How to find the time? So the next question is how to find the time. So how to find the time is, so normally, what is the time? So here, this is the displacement made by the A. So what is the displacement? Already 100 meter and this one. So total one, and we know that 60 into T. So this total one is 60 T, right? So it took time T to meet. So this guy, 40 T. So then 100, so this is 60T and minus 40T, 60T minus 40T equals 100 meter, this one. So T is going to be 5 seconds. Is it clear? 5 seconds, right? Because 20, 100 divided by 20. Is it clear? This is a normal way. So what I have done, this is we call frame of the earth. In earth frame, so we let them to meet and we are looking outside the we are in the frame of the earth. We are sitting and we see. So they meet it at this point. Okay, so we are happy. We calculate the time according to that because this guy traveled the distance 60t during the t seconds. This guy traveled 40t. So 60t minus 40t is 100. So using that equation, we found the t. Okay, so that is fine. But if you can use the relative velocity, that means the frame of, this is a frame of earth what we have done. So now what I am going to do, the frame of B, I am going to take the frame of B. What do you mean by the taking the frame of B? What do you mean by taking the frame of B? So that is another question. Okay. Now I erase this. I got the answer, but I have to check whether this is correct in any other form. Frame of B means according to the B. Normally what happens? Normally what I have done is according to the earth who is out sitting outside and watching what is happening here. But according to the B is the driver of this car or the particle or whatever thing. According to the B, how the A will appear. That is we call frame of B. According to the B, how A will appear. That is we call frame of B. Okay. According to the B, then what will happen? So you have to take this 40 again. You have to cancel this because you are going to have this as a stationary point or say stationary particle. Okay. You are going to stop this. You are going to stop the beam like this. So stopping the beam means B has no um, velocity or nothing. That means B is free. So that means we have to take this 40 away and we have to give to the other direction to this particle. 40 here and 60 here. So according to this 40, 60 minus 40, this is 20. This already you know about in physics. Okay, related to B, the A's velocity will be 20 towards the B. Is it clear? Is it clear? Related to the B, A's velocity is 20 meter second minus 1 towards B. So what is the gap? 100. Okay, so this is B's frame. To meet, this particle will go according to the B's frame, only 100 meters he has to travel and 20 meter second minus 1 speed. So time taken 100 divided by 25. So this is the fastest method. So that's why we like relative velocity because relative velocity is our problems. Okay, so solving techniques using the relative velocity is another kind of solving technique. Okay, see, as soon as possible we got the answer, the same answer. But here there you have to form the equation. Here just use of the relative velocity we found it. So the same time we got it, same same answer. In that case, well, that what it proves that so any frame according to the earth or according to the B or according to the A, the time doesn't change. Okay, right. So that's a important one. So what you can do, just copy this. So how to stop a particle or how to make a frame? How to make a frame? That means here, this is according to the Earth. I made B as a frame. B's frame. This is we call B's frame. How to make it? Take whatever B has, take it and make it opposite to that and give it to others. Each and every you have to give. Even there is a tree in between, you have to give the tree also 40. Okay. That's why normally in train, if you look outside, the trees will run the other sides. Actually, because your eyes shows the same thing. But your brains understand that, okay, I am moving, but trees are moving because they appearing moving in the other direction. But that is the understanding of the brain, not the view. Okay, so view always the eyes put you in. What is the picture? The trees are moving. You are stable, right? So, but your brains only understand I am moving. Trees are stationary. But some cases, sometimes brain also doesn't understand. If two buses are together and you are very close environment and you can't measure whether you are moving or whether that bus is moving. Sometimes you may think that we are going backwards, but actually not because of that other bus moves. Okay, so these are the relative things. Okay, so we see sun moving actually that is, but still you can have it right. Yeah. We see sun moving, actually sun is not moving. So that is the frame of what we do is that is a relative thing. Actually what is happening here, sun is center and the others are moving. So what we do according to our, we are here no earth no, so we stop that according to our frame, that is earth frame. So sun started to move again. So that is same value, so same calculation, same thing, same answer. So for calculation wise, it's good actually. So we are stable, sun is moving. So every time we see sun there and here. So if you calculate the speed, you can calculate the speed of this also, earth also. And many factors are there. So that's why the science says, okay, sun is moving and the calculation and early days calculation also same because they are very close because of the relative principle, right? So even you stop, the time doesn't change. I told you whatever frame. That's why they say so today is a full moon, there is a no moon. So likewise, so okay, you can see, and science also there is the same thing figure because it is sun centric or this earth centric. Both are both frame doesn't change because time doesn't change in any frame. That's it. Okay, you can, even if you are good in maths, you can calculate according to the frame of what do you call mass. Okay, that's also right. Right, so we erase this. Right, here, very important thing, relative velocity. So how to stop, how to make a frame, you know that I'm not going to explain that, but I will explain by just drawing a diagram, but don't copy that. Okay, for an example, there is a tree, there is a person running with the U, there is a car coming with V, there is a plane moving with W here, and upwards V1. That's it. Okay, so these are the things happening here with the various velocities. Okay, so what is this? This is according to the Earth, according to the tree. This is what is happening. Tree is attached to the Earth, so tree doesn't move. But suddenly, if you want to stop the guy, or according to this person is running and he looks around what is happening. So if you want to make this guy stable, stationary, or make it or according to this guy's frame, what you have to do is take whatever he has. Okay. Okay. So take whatever he has. Okay, and make it against to that opposite direction to that. So here he is having u in this direction means, and flip it other direction and give to each and every particle other particle. Okay, so actually what is happening is I'm going to make this zero no velocity zero no. What will I will do? I have to give this person. I have to give u velocity to this person, right? Then only this will be zero. So I don't give to this person only. I will give each and everything. You, you, you. That's it. So that means this becomes zero. This is the frame. Okay, it's a simple technique. So you're using here. Later we can learn that. I think hope we have done a straight line, isn't it? See, this is origin. So this is 2,5 point. So if I want to make this as origin, what I have to do? I have to subtract these values each and every point. Here, if I subtract 5 from here, this becomes 0. 2 from here, this becomes 0. Here, this becomes 0 minus 5 minus 5, 0 minus 2 minus 2. So this point becomes minus 2 minus 5. So the axis will be shifted to this place. So according to that, this point is minus 2 minus 5. Correct now? If the axis is here, this point is minus 2 minus 5. Correct, right? So that's why. So changing the axis or changing the points, anything can be done according to the frames. Okay. And I'll tell additional information here. This will be helpful in the complex numbers also. So what do you mean by 8 minus 5? What do you mean by 8 minus 5? 8 minus 5 means 3. Why? Because actual meaning the subtraction is, what do you mean by subtraction means? According to the 5's frame, the position of 8. According to the frame of 5, position of 8. For an example, I can explain this because I am explaining this here to help in other subject. Here, see there is a 0, 1, 2, 3 like this. There are poles, right? Or there are walls, whatever things. Okay, so 1, 2, 3, 4, 5. So according to the O, I say this is 5. According to the 6, 7, 8. So actually, what is the meaning of this? That means 8 minus 5. So once you subtract anything, that is the meaning of the subtraction is making the subtracted value as a frame, right? According to the 5 frames, what is the what about the position of 8? See, if you are here, this is 5. But if you are here, so you won't say this as a 8. You say 1, 2, 3. Okay, you say 3. So according to this person, this pole is not 8. That is according to this. According to this person, this pole is 3. So that means always keep it in your mind. Subtraction means according to the subtracted point, you see other. Okay. According to the subtracted point, you see other. That is the meaning of subtraction. So wherever you end up with the part, something like v minus u, there is a car going with the v minus u means according to what is u, the velocity of the previous car. According to that car, this is moving. According to that car with the u, this car is moving. That is the meaning of v minus u. Okay, so it's just v that we know that according v minus 0. So 0 is according to the earth, right? Understood? Okay, so there are many points. So now, so actually we can prove that there is no addition, only subtraction. For an example, 8 plus 5, what is 13? So actually it's 8 minus 5. That means you see the 8 from minus 5. So if you see the 8 from minus 5, you will say this is 13, not 8. Okay. Okay. So many points. Right. Oh, yeah, this is finished. So don't write this in. So you know how to stop, how to make the frame. Okay. So this, let's say, okay. So what I'm going to do, example. Put another example. Put example. Put earth frame, write down earth frame. Earth frame. There is a ship A, there is a ship B. Okay, so ship B, uh, okay, ship A goes with the velocity U, ship B goes with the velocity V. Okay, velocity V, angle theta to, okay, this vertical or horizontal, whatever. So there is a gap, D kilometer maybe. Okay, right. So actually, just we are talking about, right? So this is according to the Earth. Now I'm asking, the frame of A. Can you write the frame of A? Can you draw frame of A? This is frame of Earth. Can you draw frame of A? Yes. How? See, this is B. This is A. You know, A is stopped. A's frame means you have to do like that. Okay, so what happens? So before we work, we can resolve this. We can see this is V cos theta here and V sin theta here. I resolve this V as a V cos theta, V sin theta because I know that I have to take the U out and make it opposite direction and I have to give to this B. So that one is coming here, U. So later what you can do, so these two, I can say V cos theta. If I say V cos theta is greater than U, so then this is going to be V cos theta minus V. If I say U greater than V cos theta, so it will be down. I take that V cos theta greater than U. So it will be like this. So that means according to the A, the path of B will be in this direction. You know that. Is it clear? In this direction. Okay, so resultant direction. So each and every time that displacement, the distance between these two uh, ships will be reduced. Okay, so one time it will reach the minimum or the minimum distance between these two, and then it will go further, it will increase. So this is story. Do you understand? So what I explained is a big question in a simple way, because just to says how to make a frame, right? If you want to stop the B, what you have to do, you have to take the B again, opposite direction and apply to this. So it is better to resolve and after that you apply. So take V cos theta and put down, take V sin theta, put in this direction. That's it. Okay, so let me see if anything in case if these two particles are going to collide or going to meet. So what will happen? What is the condition? So if this B has to meet the A means what is the condition? Tell me. What is the condition? So then B should go in this direction because this guy can't move. So to meet this guy, so B should go horizontally. So there should not be any vertical component. So V cos theta must be equal to U. If V cos theta equals to U, so this will disappear and it will go in this direction. How long it will take? D kilometer divided by V sin theta. D kilometer, no, he has to travel, and by V sin theta. So is it clear? So these small stuffs are there because then only we can go to the relative velocity. So before going to the lesson, I have to make you prepared, right? So that's why I'm doing these things. Otherwise, straight away I can start up a relative velocity. This is this is that, and maybe I was draw the circle or something like that. I can start like that. But I'm starting like this because if I if you can understand this, then 100% relative velocity going to be easiest, and you are always we will be mastering that. So that's why in my experience I say that because many students after the relative velocity they wanted to do the relative velocity questions, and they are cunning actually. They ask questions. Okay, the other questions give me the hard question like that. So is it clear? So write down this, copy this L frame, and then copy this frame of A. Frame of A. Frame of A. Is it clear? Okay. If you want, you can draw double arrow. Okay, so if you want to draw the perpendicular line, that is going to be a shortest distance, anything. Okay, shall I erase this? Shall I erase this? Okay, so now I have explained this how to immediately change the frame, how to change the frame immediately without using any concept of relative velocity triangle or anything. So anyhow, we are not going to write like this in the exam. So we have the separate way to write the exam. So we are going for that one. That's why we are going to learn now. Okay. So shall I erase this? Hopefully. So you know relative velocity, and now we move into the lesson. Here there is a point A, there is a point B, there is a point C. Always you know that. You know displacement rule in a triangle. A to B equals, so if you do go here, you can go here and come back. So A to C plus C to B vector. It has vector means it has the magnitude and the direction. So we know that this is the displacement rule. Okay. So what we can do, I'm going to differentiate this respect to time. With respect to time, differentiate. Okay. If I do that, we have learned differentiation. Okay. And dt DAC over dt, dCB over dt. So what I'm going to get, if you differentiate the displacement, you are getting it. If you differentiate the displacement with respect to time, you are getting velocity. Velocity AB. Okay. Velocity AC plus velocity CB. Okay. So now what I'm going to do, so you don't need to learn anything higher than this. There are big concepts behind this, but I can tell. If you consider A, B, C, all these points as a particles, all are particles, then they can move here and there. So that means in that case, so by considering, write down by considering only A, B, C are particles, then this becomes relative velocity principle. A, B, A, C, C, B. Is it clear? So this is what we call relative velocity principle. Is it clear, guys? So this is not needed to you. They won't ask you in the exam or anything. But to have the knowledge, you have to proper way, no? You have to get the knowledge in proper way, not in the memorizing way. Okay, so why I get the from, at least you need to know from where we get this relative velocity principle. So actually, what is the meaning of this? According to the B, if we stop or we frame A is velocity. So if we stop, what will happen? A. So A is velocity. So then that is A according to C plus B according to C according to B. So that is the explanation. You know already we have learned in physics. Okay, so hurry up, hurry up. So shall I erase this? So this is the what we call relative velocity principle. Relative velocity principle. Okay. So very important things what I am telling now right now. Okay, so you have to, if you want, you can take a note whatever I say hereafter. Okay, right. So I'm going to erase this. So what we have to do, if the relative velocity question is given, so what is the process? So we need to learn. Okay. So keep it in your mind always, 99 percentage. Keep it in your mind, or 100 percentage, I can say, right? In a relative velocity question, only two unknowns will be found. Okay. So they will give only, you have to find only two unknowns. So this is always there. So in any relative velocity question you can take, two unknowns will be there. Okay. So that is the basic rule. So you have to keep it in your mind. Sometimes that unknowns can be the magnitude of the velocity, or it can be a direction of the velocity, anything. Okay. Right. Any relative velocity questions, only two unknowns are there. Okay. So keep it in your mind. So I'm going to erase this one. See. So according to that rule, what we have done, we have decided to put into the cases, actually not cases, type 1, type 2, type 3, type 4. So main type 4 question. There are 4 types questions in the relative velocity. Okay, so relative velocity, how many types questions are there? 4 types. So the type 1, type 2, type 3, type 4. Okay, so 5 and 6 also there, but sometimes that's related to, one is related to vector, other one is related to crossing the river. So I teach that separately. That's okay. Okay, right. Which equation I have to repeat? This one. So you are listening what I am talking, or what already written in the board. Okay, right. So that is okay. That's why I told you. So here I have to go back now. See, A, B, C. Right. So this is the displacement rule. Vector. We have learned now displacement rule. AB equals AC plus CB. Once I am writing, so you should have asked there. Right. What about that? Differentiation. Okay, that's okay, right? Differentiation. Okay, now okay. Right. So that's it. Okay, so keep it in your mind always. Relative velocity has two unknowns, right? So now what we are going to do, we are going to look into the type 1 question. So what do you mean by type 1 question? Okay, so right, before we go to the type 1, type 2, anything, there is another one we need to know. So what is how to access the relative velocity question? That is the very important part, because many students, they don't know. Even after learning this relative velocity also, they have the confusion because how to access, right? So that's why I'm going to give at the beginning. So what is how to access the relative velocity question? So you can put that as a heading, right? So put the heading. How to access relative velocity questions. Okay, this is the heading. So I erase this one. How to access the relative velocity questions. So if you know these steps, then you are through. At the beginning, you can clear everything. So how to access? The step one. Write down the step one. Whatever they are, step one. You have to read the question. So, oh sir, come on. We have to each and everything, we have to read the question. No, why you are telling that is a step one? So some students, they may ask like that. No, actually I means read the question means read the question that is in the scenario. Whatever questions are given to you in a paper, so those are scenarios, maybe a story or something like that. So those stories or scenarios must be converted to the mathematical space, mathematical thing, right? So in that case, the step one, what is the step one is the first one, very important. Read and convert to mathematical notation. That's a very important one. Mathematical notation. notation. That is very important. Okay. You have to read and convert this to mathematical notation. How to read and how to convert, I will tell you. That it is a process now. First, we will learn what we have to do. So then go for the step 2. Step 2. After converting the after converting to the mathematical notations, you have to form the relative velocity principle. You have to form the relative velocity principle. Use the relative velocity principle, and you have to form something else, right? So that is under the step 2 only. We have to write that and use the relative velocity principle. Okay, use the relative velocity principle. So how to use the relative velocity principle? How to use the relative? Hereafter there are few steps. I will fill that later. Okay, so when you want to start the relative velocity principle, you have to start with the direction known particle only, or direction known data only. So we will talk that later. Okay, so just put 2 stars. Okay, step 3. Okay, step 3. Use the relative velocity principle is step 3. Identify the type. Then only hereafter you will identify what is the type. Okay. Hereafter you will identify what is the type. So identify the type of question. So then finally, then after that, after identifying the type, that's it. You apply and you finish it. So step 4 is end. Finish the question. Okay. Right. These are the process. These are the process. How to access the relative velocity questions means, first of all, I'll tell you 100% read the question and convert to the mathematical notation. So is it clear? Just read it. Sorry, write down. Then what we have to do, how to read the question. That is our next heading. How to read the question and convert. Okay, so what we can do after copying this, I put the heading reading the relative velocity questions as a heading. Reading the relative velocity questions. Okay, so then we need to know keywords. So if you don't know the keywords, then you are not able to read the question. So convert to the, you can read, cannot convert to the mathematical notation, right? So first of all, after copying this, put the heading quickly. So at least we can go to that level, and next class we can start with the types. So that is the plan. So easily you can finish this relative velocity within 4-5 classes. If you can put 2-3 classes continuously in get that way, I did in other stream. Okay, so sometimes I see and I call them and send a message. Okay, so first 3 classes we'll put continuously in the morning, and we finish something like that. I finished there. I finished the series for them. So likewise, we'll find something like that later and during the time. So because here we are, don't try to fix everything at the beginning, because when you travel only, you can fix many things. So in that case, easily you can do. Okay. Okay. So we know that. Right. So first, how to read. Sorry, not how to read. Reading and the converting. Reading the relative velocity question. It's a heading. What heading I did? Reading the relative velocity question, or writing, reading and converting to the mathematical. What, this is the heading, no? I gave. How to read the relative velocity question. It's the heading. How to read or reading. Anything. So anything. Can be anything. Okay, can be anything. So put this as a heading, small thing. How to read. So write down. Okay, so write down first of after the heading, write down example. Okay. A ship, not a ship actually. A boy swims. A boy swims. A boy swims towards towards other bank. A boy swims towards other bank with with velocity u. Okay, so actually swims towards other bank means straight. Here you have to include straight other bank. That means straight other bank means here the person is here, he is going in this direction. That's it. Okay, so this whole statement can be expressed by velocity of the boy respect to earth, and in this direction u. Is it clear? Is it clear? So go for the next one. The boy swims towards. Okay, the next one. It's the first one. Second one, write down. A plane can fly with velocity u in a calm, calm. Is it calm? I'm not getting the calms. It's a spelling. CARLM. Is it calm? Okay. Calm weather. Okay. It's a calm. That's a calm. Let's check the spelling there. Yeah, CALM. Calm weather. Okay. Right. So that's fine. So how to that? A plane can fly with a velocity, the calm weather. What do you mean by the calm weather means? The wind is stopped according to the wind. That's why they say calm weather. They may say sometimes wind is not blowing day, a day, calm day, no resistance, nothing. So in really it's not that. Yeah. So in that case, so we go with wind W. According to the wind, planes velocity, that is okay, not related to earth, but related to wind. Okay, sometimes calm weather or still air, or what they can do. Still water, not here, other one. The man can swim with the velocity u in a still water. That means according to the water, related to word water, you have to find. Is it clear? Right? There are keywords like that. Okay. Is it clear? A man uh, intend to go to that place or some that point. So those are there. Intend to go. Okay. Other than that, these are the keywords. Other than that, other than this, you can easily convert. For an example, wind blows in the direction of north means blows means you can easily put. Okay, so so I'm not going to write any other thing other than this. If anything comes at that time, we will clarify. Okay, so what? Okay, so these are the steps. So what we have to do is now You have to read the passage and just you have to convert like this. For an example, like V, that's it. Just so I'm going to give one question. Please read that question and convert. Okay. So I'm going to give the question. Please read the question and convert. So I will give some questions related to this. I'll give one past paper question. That's better, no? Isn't it? Oh, VPW, then you didn't understand. If you don't understand, then what about others? VPW means according to the wind. Here, W is wind. Wind. P is plane. Now understood. So a plane can fly with a velocity u in a calm weather means wind according to the wind. Wind doesn't move. That is according to the wind. Wind is stopped like that. Wind's frame like that. So if anything, you write that this is the frame, this is the moving one. So you need to know. Okay, so if you write like PE, Earth is stable, plane is moving. Is it clear? If you write other way around, EP, plane is stable, Earth is moving. Right? That's the meaning of that. Right? Whatever you put here, this is the frame. Whatever you put here, that is the movable according to this frame. Okay? So this is not a water. Wind. Okay, so still air, weather. Sometimes they may say still water. In that case, you can use a W. I mentioned what is W. W is not a water, that is wind. Okay, T is the plane. So you have to mention that. You have to mention. So is it clear? So you know they don't say directions here. I don't put any direction here because I can tell you. So whatever I say, please, if you can note it down, then it is easy. Otherwise, anyway, no problem. I will tell again and again. So I can tell you 95% of questions they won't give direction for this according to the wind, according to the air, or according to the river, or according to the water. So they won't give direction for that. Okay, so keep it in your mind. So 95% question. So willful, if they give direction, that's a different thing. So you then in that case you may be able to get the relationship, show that part. So like that, show that means a different thing. Okay. So first of all, this can be done. This can be done by just first of all, we have to read the question and convert to the mathematical uh, notation. That is the very important part because many students couldn't able to do this. That's why they fail in this relative velocity. Whatever, how many times they learn. Okay. So the very important part is you have to read the question and you have to convert to the mathematical notation. That is very important. Okay. So let's see. See this. I'm going to put one question. So let's see whether you are able to convert to maths notation. Okay, right. I'll give you some to the past paper. I can. There. Okay, guys, I'll put it here. I'm having the question here. I don't know where is it. As a document, I can take it. Okay, so I don't know what is this. Okay, this is the past paper. Or you can see is okay, this is pure. That's done. This is applied. This is okay. That's it. Uh this is yeah, there are two things involving. So as a first question, I am not willing to give that one. See, that is as a first question, I am not giving to it because two things you can write no problem, but I'll go for the 2020 is better. Hopefully. So say this is 20 combined mass. It's not. Can anyone tell me where is the 20 past paper? I think this guy who you send me, no one paper. Is it 20 past papers? Uh, who? Sajid is here. Okay, no. Okay, so what I'm trying to do is okay. So I'm trying to get some past paper from the soft copy, so it's not able to do it now, right now. Okay, 18. I can say 18 also I can have. So give me a second. Give me a second. Give me a second. 18 I can have it. 2018. Okay, so this is 2018 scheme. I go for the scheme first. So easy for me to apply it, right? So I can show you whether you are correct or not. Okay, so this is the question. Right, this is 2008. What you have to do is nothing. Just read the question. A ship is sailing due north with a uniform speed related to uh, Earth. He is very good because he says everything. So just read the question and convert only to the mathematical notation. Is it clear? A ship is sailing due north with a uniform speed u. So that you can convert related to the Earth. At a certain instant, the boat B1 is observed at an angle beta of the source. This is not related to the velocity thing. So only thing is related to velocity thing you have to write. Okay, so here they will say two things. One is related to velocity, other one is related to the position. That is the displacement, right? So first of all, you have to consider the velocity only. Now, later one by one we will do. Okay, so p kilometers, something like that. we don't worry about that. Here also two boats. Okay, anyhow, boat B2 observed westward at a distant q from the ship, so that is not related to velocity. They are both boats sail in a straight line path with uniforms related to Earth, intending to intercept the ship. Sketch the same diagram, velocity. So, okay, guys, by reading that, can you convert to the mathematical notation? A ship is sailing due to the north. Okay, right. After that, there is no related to velocity. They don't talk about that. Later, they talk about both boats sail in a direct straight line path with a uniform speed v related to the Earth. Okay, velocity triangles. Okay, that's it. That's it. Don't after that. Don't read it. Okay, so that's it. So what they say, a ship says it A related to the sailing due to the east or north. I don't know. with the velocity. So only thing. Other one is V1 related to Earth is V1 or V2 related to Earth is V2. Is that or is that? I don't know. I forgot this. What is they say? Okay, so it is not possible to get it again. Okay, guys. Okay, so whatever it is. So the first one, focus on the first one. Later, I forgot it. Okay, so what they say, if the A sails in the direction of due east respect to Earth, then that is in this direction. That's it. So according to that, so that is the okay. So that's a way of uh, you know we have to represent the whole thing in mathematical notations. Is it clear? Okay, so I think it's better to conclude the class right now because later we will continue this. And what I expect from this, please go through each and every past paper what you have and relative velocity. Try to convert only the first few lines are there to the mathematical notation. That's it. Because after that, from the mathematical notation only, we make the relative velocity principle. From that only we go to the find the types. From that only we do the question, and that it's like a climbing on the ladder. So you have to take the leg from the step to go to the another step. That is the meaning of ladder. So you have to give up. You have to give up the steps. So likewise, the same procedure in relative velocity we use. First, after converting this, then totally we forget about the theory scenario. We don't need scenario hereafter, right? So we need this notation. From the notation, we form the principle. Then we don't need the notations also, only principle. From the principle, we identify the type. So then after that, we don't need the principle also, type. So from the type, we do the question, then answer. That is the procedure. Okay, so guys, today I'm going to conclude right now. And this is the homework you because I can't put all the questions right now. I have questions, but it's the order if you can go to that. 2019. Okay, so this is 2020. Try to just convert to the mathematical notation. 2018 we had now, so it's better to 2017 and 16 and 15 and 14. Okay, so these past papers try to convert. Yes, thank you very much, all of you. Have a nice sleep. Have a nice day, nice night. Okay, and happy Pongal and for all. And that's it. So we will start after that. Hopefully, it will be okay. And uh, that's it. Okay, please, if I ask any past papers, this give this because the other batches what they say if you ask the past papers, they straight away send to the WhatsApp. Sir, here it is. Then I put in the strength. So it's easy for me other than I'm getting this past paper here and there. So see, because it's messed with the past papers because actually I want to have the wordings. Otherwise, I can tell the past paper what is the question, right? From the memory, but that doesn't work. So this here doesn't work anymore. You have to read and convert. Okay, guys, bye. See you. Okay.